This is Integrated 2, Chapter 5, Part 1, Day 4. The first thing I want to do is, it's been a while since I've made videos, and I made some changes to my note page, so I wanted to kind of point that out. And I think in the last video I was talking about how this A, if it opens up and if it's normal, and I had that in the factored form as well, and I went ahead and I made a change to my notes and I took it out of the factored form, and I kind of want to show you why. I think I put it there sort of without really thinking about the fact that standard form A is more reliable than the factored form A. And you'll notice this is a capital A in standard form and it's a lowercase a in factored form. And sometimes when you see factored form, it's written in a different form as well. So let me go ahead and pause this and set up a problem just to show you why I took it out of factored form. And I want you to determine your A if it opens up or down and is normal, etc. from standard form and not factored form. The point of it isn't necessarily to go through in all these steps, but what I really wanted to do was talk about the A thing, where if I look here, I can see that my A is -4, and my point that I'm trying to make is the A is more reliable for determining if it opens up or down and is steep or not in standard form. So this is standard form, my A is -4. This tells me this opens down and that it's steep. Right? But what if I factor it? There's a couple different ways I can factor this. So what if I factor this by taking out a -2? I'm going to end up with 2x squared plus 9x minus 5. And then from there I could go on and continue to factor it by putting it on the diamond, but that's not really the point I'm trying to show you. But what if I went over here, and we've never really done this because I've always told you I want this term right here to be positive. It just makes everything easier. But what if I had actually factored out a +2 and I get -2x squared minus 9x plus 5. And then again, I would go through and I would factor this using the diamond, and I would sort of continue. And like I said, the point of that isn't to go through here. So ultimately, this would factor as y equals -2x plus 5 times 2x minus 1. And ultimately, this one would factor as y equals 2. I think it's x plus 5, and then I think it's -2x plus 1. So the bottom line is they're really similar, and what I want to show you is if I go over to Desmos, I have them all factored already. So here's my original parabola, and you can see my A is negative and it's steep. But here my A it's negative, but it's not as steep, but it makes the same parabola. So that's kind of a problem, right? Like if I go by this A, I don't think it's going to be as steep as if I go by this A. And look at this one. I factored this one, and you can see it's the exact same parabola. It's changing colors to green. But you can see the A here is actually positive instead of negative. So again, long story short is I went through and I just want you to focus on the A when it's in standard form, not when it's in factored form. Let me pause again real quickly. I took out the A for opens up and is normal. Honestly, I kind of regret going over this. I think if I hadn't, no one would have noticed, but I do want you to realize the A in standard form is more reliable than the A in factored form. All right, so let's jump into today's lesson. Interestingly, I'm trying to match it up with the standard form up here. So you can see my A is 8, but my B is 0, and my C is -18. So what do we do when a B is missing? I know we've already dealt with this a little bit, but I think it's worth reiterating. So first thing I'm going to do is my initial factoring. I think the biggest number I can take out of here is a 2, so I'm going to get 4x squared minus 9. Now I'm going to go to my diamond here. My A times C is going to equal -36. My B is again 0, and I will put this over 4x. So as I go through, 1 times 36, I'm not going to get a 0 out of that. 2 and 18, I'm not going to get a 0 out of that. A 3 and a 12, a 4 and a 9, but a 6 and a 6 if one's positive and one is negative. Now I will simplify the side fractions. 2 goes into 4 and 6, and over here it does as well. So there we go. We have our factors. 2, don't forget this 2. 2x plus 3 and 2x minus 3. So we can use our factors to solve for the solution. So 2x plus 3 is equal to 0. 2x minus 3 is equal to 0. So I'll subtract 3 from each side. So my x is going to be negative 3/2 here. And hopefully we're okay with the idea that it will be positive 3/2 here. So there we go. I have my x-intercepts. Now, kind of run out of room here, right? So plug in 0 for x to determine the y-intercept. So my x-intercepts are going to be negative 3/2, 0, and 3/2, 0. But let's plug in 0 for my y-intercept. So 0 squared, right? I'm going to get... Sorry, my dog is growling and I'm wondering what's going on outside. So my y-intercept is going to be 0, negative 18. And when I go over here to step 7 and 8, I want negative b over 2a. Well, think about it. My b is 0, so it's going to be like negative 0. I mean, there's no such thing, but whatever. Over 2 times 8. So I'm going to get 0 over 16, which is 0. So that's going to be my axis of symmetry, right? There's my axis of symmetry right there. And then for step 8, I'm going to plug that into the equation. So y equals 8 times 0 squared minus 18. I'm going to get y equals 0 minus 18. I'm going to get the same one, right? And by the same one, I mean, look, my vertex is the same as my y-intercept. So let's go ahead and graph that and see what that looks like there. Our A is positive and steep, so we have a pretty steep parabola there. But like we mentioned, we have our x-intercepts, but you can see the y-intercept is the same as the vertex. So when that B term is missing, don't be surprised at all if your y-intercept ends up being your vertex. It's just because there's no shift taking place in the left and right. All right, let's go ahead and set up the rest of this video and call it a day. All right, so at this point, I kind of want to talk about what I think parabolas are actually important. They actually do make real shapes in the real world. And I think that, so I kind of made this worksheet up just so you could see some of the uses. So this problem we'll go through together has a cliff diver jumping into water. This one has a catapult launching a projectile. And this one has a diver swimming under a boat. So these all make parabolic shapes. And I just want you to see like the importance of the vertex, the importance of the x-intercepts, the y-intercept, like how these points actually might become important as we sort of go through here. So give me 1 second. My pen's not working. I don't know why. Child is messing up my tablet. All right, so anyways, it says a cliff diver jumps into the water in a parabolic shape that is modeled by the equation y equals negative x squared plus 4x plus 5. Assume the x intercepts the water. So this is our water, and the y represents the cliff. So he'll be jumping into the water, right? And all the measurement are in feet. So how high was the cliff the diver jumped off? So let's go through and let's sort of make our main points here. So first of all, the biggest number I'm going to factor out here I think is a negative 1. So I'll say x squared minus 4x minus 5. Hopefully we're all okay with that. I will put that on the diamond. I will get negative 5 over negative 4 with a 1x on the side. If I sort of go through there, 1 and 5 looks like it could work if the 5 was negative and the 1 was positive. Negative 5 times 1, negative 5 plus 1. I'm not going to be able to simplify those, so my factors are going to be, and I know I'm going through this fairly quickly, but at this point, you should definitely be able to follow. If not, I think you need to spend some time on these. I would pause the video as well to see sort of how you're doing here, but I just feel like some of these videos definitely drag. I'm sure you agree, and I don't want to take longer than I have to on them. All right, so I get these x-intercepts of 5, 0, and negative 1, 0. So I'll go over here. I put a point at 5, 0 and at negative 1, 0. I will now get my y-intercept. And again, I'm going to go back up to the original equation for my y-intercept. So my y-intercept, if I plug 0 and 0, I'm going to get 0, 5. So my y-intercept is going to be here. 1, 2, 3, 4, 5. And now I need my axis of symmetry, which is going to be negative b over 2a. So I'm going to have negative 4 over 2 times negative 1. So negative 4 over negative 2, that's going to be 2. So I have my axis of symmetry here at 2. And then if I plug 2 into the equation, I'm going to get my vertex, right? So I'll just go over here and say y equals negative 2 squared plus 4. And like I said in the last video, I think it was the last video, I'm going to do this by hand so you see order of operations. This isn't negative 2 squared, this is 2 squared, and then it turns negative. So we're going to deal with the 2 squared first. And now we will get minus 4 plus 8 plus 5. So I'm going to get 9. So 2, 9 is going to be my vertex. Now I'm going to go ahead and answer these questions so you can see. And again, I have this sort of symmetric point. If this is the axis of symmetry and I have a point 2 away to the left, I have a point 2 away to the right. So this sort of becomes my parabola. And again, don't forget, this is like a cliff right here, right? And this is water. So now we can answer these questions. How high was the cliff that the diver jumped off? Well, it looks like he jumped off the y-intercept of 5, right? So it was 5 feet tall. That's what he jumped off of right here. And he sort of jumped into the water. What's the highest point the diver reached? Well, he got as high as 9 feet, right? That was the vertex. He got 9 feet in the air. And how far from the cliff did the diver land in the water? Well, he landed over here at 5, 0, so he landed 5 feet away. So I hope that makes sense, that the diver sort of made that arc and landed in the water right here. Again, you can sort of use this to represent a parabola. Yeah, my kid definitely broke this thing. I'm going to have a chat with him. Not happy. Anyway, if you kind of go through 2, it talks about a catapult, and so you need to mark the X and the Y and sort of go through all those steps and try and answer the questions: how high the projectile hit, what the highest point of the projectile was, how far from the castle wall the projectile launched, and then the diver swimming underwater, how far from the boat did he go, etc. So you sort of kind of represent these things with a graph and then answer the questions that go with them.